An inverse function links the output of a function back to the input. So for example, we've got a function g and the input is 2 and we get the output of 7. The inverse function of this, which we write in this way with that superscript -1, so the same kind of way we write the inverse trig functions. If we take our output here and put it into this inverse function, it should get us back to where we started, back to the input. And that's what an inverse function is. To find it, we need to follow the steps in the middle of the page here. So I'll talk you through an example and then there's a chance to have a try at another one. So we've got f of x is 5x minus 4 and we want to find the inverse function of this. First step is we need to rewrite it and we're going to write it with y is equal to 5x take away 4. So what we've got here, just to think it through, x is the input and y here is representing the output for our original function. For our inverse function, we're going to need to rearrange our formula here to make x the subject in terms of y. So flipping around the way we've done it. So to do this, we're just going to follow our normal rules for solving an equation. And we get x is equal to y plus 4 all over 5. We now need to rewrite this using our proper notation. So f to the -1, the inverse function of x is equal to, and when we write this, we're going to replace the y here just with x. So this is the inverse function, and we can check that it works out. If we just use a simple number in our first function, so say let's use 2, we'll get 5 times 2 take away 4, the output would be 6. If our inverse function is correct, if we use this as the input, we should get 2 as the output. So we've got 6 plus 4 gives us 10, all divided by 5 does give us 2. We can check that works. This example is really similar. Have a practice. So same steps. We're going to start by writing this out as y is equal to our expression. We're going to rearrange to make x the subject. And then we need to rewrite this using the correct notation. So it's g we've got this time. So it'll be the inverse function of g is equal to our expression here. Remember, we're going to replace y with x. And we can check that that works out. So looking back at our original function here, let's choose a value that will be nice and easy to work with. Let's go for 4, because then we've got 4 plus 2 is 6, divided by 3 is just 2. So checking our inverse function works, we'll use the input of 2. So we've got 3 times 2, which is 6, take away 2, gives us 4, which is where we started off here. So we can check that's correct. Have a try with the questions of these. So all of these have a pair. Some of them are a bit tricky to spot. So I'm just going to rewrite some here. So this one. Now, if we think about expanding that, that's equal to a quarter. If we multiply the brackets, we've got 16x squared. which is the same as 4x squared. So the original way they had written this was quite confusing. So look out for the pair for that one as being 4x squared. I think most of the other ones are fairly straightforward. So what you need to do for this task is start with any of the functions, work out their inverse, check it does actually work for the values you're putting in there, and then find its pair. So you can pause now, or I'll talk through the first one here as an example if that's useful. So we'll start off by writing y is equal to, and then we need to rearrange. So we'll start by dividing by 2. And then plus 6. We've rearranged it to make x the subject. So now we rewrite it using our notation. So it was a, we're to use this correct notation for our inverse function. It'd be this. And we're looking for one of our other answers here to match that. Yep, which is down here, which is t of x. So I'm just going to use the table here to show a of x and t of x are the inverse of each other. So keep trying to match up these pairs. And there's also some extension questions here to get you thinking a bit more. Pause the video, answers coming up in a couple of seconds. So just to help you make sense of this. So for the first functions here, you can see so we've got a and t are the inverse of each other. I've put them just together over one side just so you can compare them, so that might be useful. Again, like b and q, I've got the pairs of those over on this side.